I want to go back and do a little bit, just add a couple of little points to the last lesson. We had this slide there. James, you're Donald Duck on your top. Okay. James, your speech is Donald Duck again. Okay. We looked at Collins last week. He commits the logical fallacy. James, okay. Collins commits the logical. James, you're Donald Ducking. Can you go out and come back in? Okay. Collins, we looked at him last week. He commits the logical fallacy denying antecedent. I had this part on the slide and this also. He fails to acknowledge that scientists have not even examined an infinitesimal part of the rocks. Now, he said we haven't found the various pollen, and he mentioned grass as one of the pollens they hadn't found. Well, they only looked at a very, very, very tiny portion of the rocks, and I believe I've seen some claims that there was actually some of this pollen in there. But what we found is, and they have discovered now, that dinosaurs ate grass, and we noticed that in the fossilized dinosaur dung has grass in it. Here's a link. You can go to this link. There's another one here. This one, you'd have to click on it to see it. And you can just type it in, dinosaurs, Google this, dinosaurs munched on grassy snacks. That's in Nature magazine. That's a high-powered science magazine in England. And here's another one in another magazine, and it's on the history of grass. And this is, of course, in fossilized dinosaur dung as well. So again, we've got in New Scientist, fossil dung reveals dinosaurs did graze grass. This is a New Scientist magazine. You can Google all of this and find all of this information. But here's 4 different sources that claim that dinosaur dung has had grass in it. But grass is supposed to have evolved after the demise of the dinosaurs. And of course, what we're saying here is these dinosaurs during this time, the grass was there, yet he's saying we didn't find the pollen. But we know now the grass was there when a lot of this rock was supposedly laid according to the atheist views. And so the fact that it's not there, but the grass was there, is very telling. So it shows that his argument is flawed. But of course, we know it's logically flawed to begin with because it denies the antecedent. Collins might have been referring to the Grand Canyon spillover theory, and I had this also. And we had this slide here, this part, but here's another one. This is in National Geographic, the spillover theory in National Geographic. It's a YouTube source. So you can go to YouTube and actually see this. And of course, we'll get into this just a little more tonight. So I want you to be aware of this. Okay? This is just additional information to the last lesson. Collins resorts, of course, to uniformitarian assumptions, and I warned you that they would very early in our study, that they will argue, they will use uniformitarian arguments to supposedly prove their case. Now, here's our next lesson. This is lesson 42, and we'll be starting this lesson now. The Biblical Flood. This is Marion Fox, and here we have Lake Bonneville. Now, this is in Utah. We see the states of Idaho, Utah, and Nevada here. This area is Lake Bonneville. These are called paleo lakes, old lake stages, Bonneville Lake and Provo Lake. So Bonneville Lake was the full area. And so we have here Lake Bonneville. Now here's the present Great Salt Lake. And it's fairly large, but Lake Bonneville covered a good portion of the state of Utah. So this was covered with water. I believe this was after the flood, Lake Provo and Lake Bonneville. And we'll see some more information about this. Here's another map of it, and here is the ice that was laid during the flood, and the ice run out through here through the Columbia River. Now then, there was an ice dam up here in Idaho and the Montana border called formed Lake Missoula, and this ice dam would break, and it happened more than once. And then this water overflowed and scoured off everything down to the bedrock. This is called the Scab Lands area in eastern Washington state, the Scab Lands. And so here are the lakes that we have here. Back here's Back Lake Bonneville, the present Great Salt Lake. There was a lake over here in eastern California and throughout Nevada. And there was a lake down here and of course, these are all lakes, and there's evidence these lakes did exist. And so these lakes then overflowed, and they cut the Snake River channel, for example. One of them did. And so here, the lakes, after the flood, they were here, and they began to dry up because of the dryness of the area. But of course, while they're evaporating, they're going to produce rainfall over in this region here. So once they dry up, the climate changes. So we see a change in climate here throughout this region. So this is the modern lakes that we see now. There's Great Salt Lake, and the bulk of them now don't even exist. Okay. Now there were lakes over here in Arizona that we don't even have on here, and that would be, we'll go back to it right here. And so Betahoche, I think is how it's pronounced. That's the lake. So you would see information about that. It was about the size of Lake Michigan. This area is a pretty large area. Utah is a fairly large state in area. Have some pretty large lakes. Now the water in these lakes, of course, would cause the continent to sink a little bit into the magma due to the weight of the water. And as the water evaporated, Isostasy, it would rise. The continents would rise. That would produce earthquakes as well. Here, the arrows show flood routes coming from these lakes here. And we'll follow this up a little bit more here. There was a lake down here this is, of course, the state of Oregon. Okay. Now, here's Idaho and Utah, and the Bear River here was cut by this, and the former course of the Bear River, it went across here, but when it overflowed, and this will be coming out of Bonneville Lake, and the Red Rock Pass cut through, and it cut through here, and then this cut the river and made it flow in this direction, so it flowed down into the Colorado River and Wyoming and so forth. So this is the Snake River here. It cut through here, Bear River, and it goes down to the Snake River. Okay. The Haunton, there is a small lake here in Lahontan in the state of Nevada. Here's Bonneville system, and of course these are Pliocene lakes and marshes. These existed in this region right after the flood because there was a lot of water here. And of course, that would cause rainfall. But once the water evaporated, the barrier along here, the mountain range, the Sierra Nevada range, would not allow water to come from the Pacific Ocean and replenish this water here. And so it dried up and the climate changed. The climate began to change at that point. And we'll come back to these in just a minute. Right here is where the Lake Bonneville overflowed, and there's a maximum flood stage. It cut down through here and went down through this, forming this river here. And this is, and then here's Lake Missoula. Missoula flooded as well. It was a Missoula flood, formed these red ones. and these will be in this up here. Here's Lake Missoula, and this when it overflowed. What we had here is there's glaciers here that block the water, and the water would melt, form this huge lake here. Montana is the third largest state in the United States. It's very large, and so this lake is bigger than a lot of states that are east of the Mississippi River. It's lake area, Lake Missoula, and of course this was very deep. And when this ice dam melted, water began to flow through here. It scoured off down. This is called the Scab Lands. It scoured off down to the bedrock. So there's not any topsoil in a lot of this region in here. That you can do a search on this on the Scab Lands. It apparently what happened when this water flowed through, it actually went back clear to Eugene, Oregon, formed up and then flowed back out through the Columbia River. This is the Columbia River here. So that's your flood path. Now here's the Cordelian Ice Sheet up in Canada, Puget Lobe, and there's some lobes here. Now this lobe here blocked and formed this lake up here, this huge lake in Montana, Lake Missoula. Missoula, Montana is a town or a small city in Montana right now. We had two ice sheets, and I believe that they were deposited at different times as the planet that caused the flood, which I think it was Mercury. The planet then lost its ice rings, and probably this first one right here was the first pass, and the second one, this one right here, was the second pass, most likely. So this ice here was deposited. There was a region right between them. God providentially, I believe, allowed that to occur. And so the animals could traverse between these ice sheets, come down to North America and down through Central America to South America. And of course, at this time, the state of Florida was wider and more, the continental shelves were uncovered at this time to a large extent, okay? And of course, then this ice melted as it melted, and the water out of these fluvial lakes, like Lake Bonneville, flowed out. Then that would raise the ocean levels. The ocean levels would rise due to that. Here again is a better picture of it. Here's that region between the two ice sheets, and Laurentide Ice Sheet and the Cordelian Ice Sheet. And again, I believe these were deposited at different times during the flood. Probably the Laurentide Ice Sheet was deposited first. It covered up a good portion of what we know as Canada, and the Cordelian covered up most of the rest of Canada. So most of Canada was covered by these two ice sheets. And parts of the United States were covered here by the ice sheets. Now, Laurentide Ice Sheet, thickness here, this tells you the thickness. The darker it is, the deeper the thickness. This is in meters. A meter is 39.37 inches. It's a little more than 1 yard. And so what we have here, it's 2.54 centimeters make an inch, and a centimeter is 100th of a meter. So again, we have a pretty thick ice here, and this is up in Canada. Here's the Great Lakes, pretty deep ice right over here and here. And this, of course, the darker it is, the deeper the ice is. You can see the scale on the bottom. Okay. Now, the Earth's gravity field has anomalies, and that's everything is not exactly linear, smooth. And there are regions where it has a stronger gravity. And so the Earth's gravity 0 would be the kind of the average. And of course, the negative would be the weaker gravity, the blue area. And places like out here in the Pacific Ocean, here's the ocean. This would be the Indian Ocean out here. Has some weaker gravity because it's just water here. Water is not as dense as land. Here's mountain ranges, so it has a stronger gravity due to the mountain ranges. And here's the mountains in North America and Mexico down in here. Mexico is part of North America, but I'm just talking about Canada, United States, Mexico, and North America. Here's mountain ranges, further additional mountain ranges. This here is out in the ocean, I believe. There's Greenland up here. But this is the gravity fields as they were different. Now satellites, when they're circling the Earth, and I'll make them circle like this, they'll go down here and they'll rise up. They'll go down here and rise over here. They'll rise up here, gravity's weaker, and then they get close to the Earth here. So they actually just do this and they just follow that gravity curve. So they don't go in a purely circular arrangement. The gravity affects them. Let's go back to the North American glacial lakes. Here's Lake Missoula, and that's a map of where it was. And then right here is your Scab Lands that were scoured off. Then there was a lake, Lake Columbia, up here as well. Now this lake breached through, and it formed a flow of water as water began to flow out of it. Once it begins to cut through the rocks, it'll scour the rocks pretty quickly. Flowing water can be used to cut through the rocks of all kinds of rocks, and even through metal. And so water can be, and jets of water can do that. It can be very abrasive. So what we have here then, there's Lake Missoula and there's Lake Columbia. Lake Columbia is the largest lake in itself. And again, this water flowed out of these lakes into the Pacific Ocean. Now this would be ice cold water, nearly freezing water as it flowed down. This would affect the water in the Pacific Ocean. Of course, it would raise the level of the ocean slightly as this water moved out, and the land would rise due to isostasy as it flowed out. And of course, now then once this cold water flows into the Pacific Ocean, as it goes south, it will affect the climate for a while until that water finally warms up. It will affect the climate of the Earth, particularly on the west coast of North America. So again, we can have climate changes in climate, rapid changes in climate. Here's a computer rendering of the Glacial Lake, Missoula, Oregon Public Broadcasting System. That's a computer rendering of it. They know the boundaries of the lake. They can see the evidence in the rocks as the water lapped up on this. You can tell there's a lake there. Here's some post-diluvian floods again. This, of course, is up in the area we're talking about. This is the Scab Lands here. That's what they look like. I was talking about. They've lost almost no topsoil there. Now, here's some layers of sediment. And the layers of sediment here, the B is for Lake Bonneville, and the M is for Lake Missoula. And so Lake Bonneville breached first and put its rocks or soil into the sediment, and then Missoula came through next, and the water from it flowed out. Now, Missoula breached more than once, so we can keep that in mind. So apparently they flowed through more than once, at least Missoula did. Bonneville may have just flowed one time out through it. Once it started cutting, it cut a deep channel and emptied itself out pretty good. Here is Hudson Bay. I flew over that when I was coming back from Russia. I flew over it and went over this part of it over here. You don't have it on the map. But I flew into Chicago. But what we have here is, here's Hudson's Bay and there's Lake Agassiz. Now, of course, this was blocked on the north by an ice barrier. So this was an ice dam across here. This was a large lake. Now, we still have a couple of lakes left, 2 or 3 lakes here. And here's the northern part of the United States. This is Canada here. And here's North Dakota and Minnesota. And there's a boundary with Canada here. There's Wisconsin, the states of Wisconsin. And so what we have here is this lake went clear down into Minnesota, and parts of South Dakota even were covered by lakes. These are lakes that we find here. And they were large lakes. They're quite a lot bigger than Lake Superior. Look at Lake Superior. This is one large lake here, Lake Agassiz. Here's a map of it that shows it a little better. Here's Lake Agassiz, and look at Lake Superior. The biggest of the Great Lakes is just dwarfed by Agassiz. So this lake was quite large. Okay. Now, once the boundary, the ice that was here began to melt, this water can flow into Hudson's Bay then. So it flowed into Hudson's Bay. Hudson Bay, sometimes called Lake Hudson. It's a brine lake. It's a brine lake. It's not totally saltwater, I don't believe. And now here's Lake Agassiz, and here there's Lake Ojibwe way over here. This, of course, is the southern end of your ice, and the ice sheet formed a dam to keep the water that had melted from flowing into Hudson's Bay through these channels, through these rivers. But once the ice melted back, then it flowed into Hudson's Bay, and then finally. But right here, we find an interesting thing here. This right here fed into the Ottawa River. And so right here is Lake Huron. So we'll come back to this a little bit. But so there was these lakes here, and the scientists agree, and I believe they're correct, that these lakes existed. I think the evidence is conclusive. To me, it is. Yeah. And of course, the dating here, I believe, is wrong, but they're not that far off, but they are just a few thousand years off. And so here's Lake Chicago, it's called, and they have these lakes, the ice begins to melt. Supposedly 7,000. Here's Lake Chippewa and Lake Stanley, early Lake Ontario, early Lake Erie, and there's Lake Huron. Say, that's Huron, what's now Huron. 4,000 years ago, we have these lakes forming, and so we have several different lakes. Now this lake's disappeared basically here. Again, the Laurentide Ice Sheet was forming as it melted, would form lakes because the water can't run off. Now Lake Ontario is here, and here's your ice sheet. And so it blocked an Oneida Lake. Here's Rome, New York, Syracuse, New York. This part of New York was covered with water at this time. And Cayuga Lake as well. There's Lake Ontario. Now here's the present boundaries of Lake Ontario right here and here. So it was larger than it is now. There's Buffalo, New York, Niagara Falls. So here it would have flowed out into the Atlantic Ocean, but the ice sheet blocked it. So once it melted sufficiently, it could flow down the St. Lawrence River down into the North Atlantic Ocean. This is the Lake Iroquois, it's called, Lake Iroquois. That's the name of this lake. Here's another map of Lake Iroquois. This was all covered with water here at one time. And the Laurentide Ice Sheet, as it began to melt, as it melted, it was retreating north in the Adirondack land. Now, this water flowed across through the Mohawk River, flowed down into Lake Albany. Lake Albany was a large lake at that time. And here's another lake we don't even have anymore. So this water backed up in here. Here's the Green Mountain upland. And now as we look here, this is very important because now we get another picture of it here, just on a bigger view. And here's your lake here. And it was blocked. There was where ice had bulldozed up a dam, basically, like a dam. We'll get to that in just a minute. And then finally, once it breaches it, this large lake flows out quickly and cuts a deep channel to the Hudson River. And here's New York City. This is called the Narrows Dam. There was a dam here formed by a glacier. Glaciers, as they move, can like bulldozers, they can bulldoze soil up and form like a levee. But once this breached it, it cut a deep channel in the Hudson River. And so that's why New York City has such a good harbor, one of the best harbors in the world. It's a deep water harbor. And so the ships can come in there to New York City and into the city itself. And this is supposedly 13,000 years ago. I believe their dating is wrong. And again, of course, they here it was above, the continental shelf was above sea level at this point, and it cut down through, the channel cut down through here. And so this cut a river, a channel, what's now under the water, under the sea, undersea channel. Canyons, we call them. We talked about them earlier. So I believe that this all happened very quickly. This water, now there was water flowing out of this lake to the Mohawk Valley here to help fill this up. Now, the Mohawk Valley and the Glacial Lake Albany is called Glacial Lake Vermont, Champlain lowlands, and the Adirondack Mountains. So right here, then this water ice dam formed it here, but the water melted, began to flow in and fill these up and cut this deep channel. Okay. The Hudson River, a moraine, is like an ice dam. Either a moraine, which is soil that's been like bulldozed up by the glacier, or an ice dam itself. And impounded Lake Albany was breached. Once it was breached, the rapid flow of water cut the Hudson River channel very deeply. A rapid flow can cut it very quickly. Just a gentle flow doesn't cut hardly anything. Doesn't do any cutting to speak of at all of a channel. The Grand Canyon was no doubt cut quickly by large amounts of water. River was blocked by a moraine at a place called the Narrows, and that's in New York City. A place called the Narrows. And this massive flow of water breached the moraine and formed this deep channel. And several hundred feet of the continental shelf was above sea level at that time. Cutting the Hudson Submarine Canyon was cut at that time, I believe. Extensive amounts of it were cut. Now, the other parts were probably cut whenever the waters flowed above the land and flowed off during the tidal action, during the 150 days of the tidal action of the flood. It immediately lowered the temperature of the Gulf Stream, because this vast amount of cold water, it would be fresh water and it would be less dense than the salt water, so it would move to the top of the ocean. And so it would have this cold water cooling the air as the air flowed over it. And so the temperature of the Gulf Stream would be lowered, and that would affect the climate as far as Europe. Within a few months, the temperature of Europe was greatly lowered by this. This could explain some of the what I call whipsawing of the temperatures of the continent of Europe from historical records that we have. Here's your Hudson Valley shelf. I believe was cut to a large extent at this time. And of course, then there's deeper cutting of the channel down here as it goes down. This probably right in here was cut. This part here probably was cut to a large extent by the flood itself, as the waters flowed above and below. Here's the Gulf of Alaska, and here's some fresh water, and there's oceanic salt water. You can actually see the difference in them. It's a picture that I picked off the internet. So that's the Gulf of Alaska. That picture was taken. Very interesting. You can see what we're talking about. Here's chlorophyll for plankton in the Gulf of Alaska. And of course, the amount of chlorophyll is due to the temperatures will tell you how much there is there. Chlorophyll of plants, of plankton, they're called, would be food for various animals. And so then those animals would provide food for other animals. And so we have a chain of events, one to the other. Here's the Gulf Stream, and this is the various temperatures of the Gulf Stream. Right here is eastern United States. There's Florida, east coast of the United States up here. And right up here, this is Cape Cod right here, Massachusetts. And up here, that's probably Maine, about right there, north end of Maine. And we get up into Prince Edward Islands here, and we get some of the other provinces up here, New Brunswick and Newfoundland up to the north up here. Okay. So, but you see the temperature as it cools off, it goes up here. This is a good fishing region because the water's cold and they'll hold more oxygen. And so the fish can breathe easier with more oxygen in the water. The warmer the water is, the less oxygen it'll have. We've already been through that. That's just a simple principle of physics. Here's the forming of the Gulf Stream as it moves across. The Gulf Stream part of it goes over here. And what we have here, here's your St. Lawrence River. The Great Lakes flow out through here. And of course, the warm water moves up. And then some of that warm water then moves down here. Some of it goes on up into the Arctic Ocean. And as it cools, as it moves up, there's Iceland here and there's Greenland here. Now, England, I was there in about the year 2000, but England here on the West Coast, there's a region that they planted palm trees on, and they've been able to survive and grow because this Gulf Stream keeps them warm. It doesn't let it freeze. It doesn't freeze. Again, let's go back to the state of New York, the Lake Iroquois, and this lake here went across, and this region, if I can tap my mouse here, this was part of the lake here. And so Glacial Lake. And there's Fort Drum right now. That's, again, the boundaries of the state of New York, Lake Ontario. Now, what we have is it's cut down through here to this area, and it cut a channel, it cut a deep channel for it. Here's our present Great Lakes. Present Great Lakes that we have, the present ones. The weight of these lakes, of course, water has weight, along with the glacial ice would depress the condensate into magma. We call this isostasy. We've talked about this already, isostasy. And it's from isos, the Greek word isos means the same, and stasis, to stand. So they stand at the same level due to their weight. And of course, it's like a boat. If you have a boat floating, and when you step into the boat sinks into the water due to your added weight. If you step out of the boat, it rises in the water. Basically the same basic principle of isostasy. The sudden drainage of these lakes into the oceans, Bonneville, Columbia, and Missoula into the Pacific, Dazes and Ojibwe into the Atlantic and through Hudson's Bay, would have a cooling effect on these oceans, particularly in the northern part of these oceans. And of course, would affect the climate for a number of years until this water was able to warm up due to sunlight and other things warming it. The sudden release of the waters of the lakes, Bonneville, Columbia, and Missoula, caused extensive erosion. A region we call the Scab Lands in the eastern state of Washington. The adjustments in isostasy probably caused earthquakes and volcanoes even. Perhaps that triggered volcanoes as well, because as this isostasy moved, the rocks had to move with it, allowing magma to flow out. Tsunamis probably occurred when vast amounts of water entered the ocean very rapidly, and that would form tsunamis. And these tsunamis can move all the way across the ocean. A tsunami created in Japan can reach the United States a day or two later. It travels about 200 or 300 miles per hour through the water. Tsunamis do. So they move at pretty good clip. So tsunamis probably occurred at this time as well. That release of large amounts of cold freshwater would affect the climate in the northern hemisphere for some period of time. Freshwater, of course, is less dense than saltwater, and the colder freshwater from melted glaciers would cool the air moving over the ocean. And of course, then that cold air would move across the land masses, particularly in the northern hemisphere. This would trigger climate-related events such as the Younger Dryas. they're dated, according to the atheists, by about 10,000 years ago. It's not too far off, but they're off a bit on their dating of this. It's the tundra plant called dryas. And so here's ice here, and these plants will continue to bloom even with ice around. That's the dryas. This is one of the plants, and they're very pretty to look at. But dating of the drainage of these lakes based upon two things. It's based upon radiocarbon dating and barbs, the counting of sediment layers on lakes. So these are the two ways they dated. And of course, their assumption is there's one layer each year. And of course, that assumption is based on uniformitarianism. And of course, they've resorted back to uniformitarian principles. Let me point out radiocarbon dating has its limits, and we will cover it in some detail a later time. We will cover it right now, however. This is documented in this source right here, and you can pause the file and write this down and go to this website. And this is at Harvard University, but there's documentation of this at this point, how they dated it. Here's in Scotland. Some of my ancestors came from Scotland, and this is Glenroy. It was a glacial lake that caused the shorelines to look like roads around the sides of the mountain. So we'll see a picture of it. It's not a very large lake. It's like the lakes in the United States, like that we've talked about. But it is a glacial lake, a post-diluvian lake after the flood. There's a picture of it. I would love to go to Scotland sometime. I went to England, but I didn't go up to Scotland. And here's the shorelines. These shorelines across here look like roads. Here's more shorelines up here, more here, and more up here. And this shows where the lakes went to. There's your ridges, or your shorelines. And this was all covered with water at Glacial Lake at one time. Of course, the ice melted and the water flowed out to the ocean. The water did. When this ice melted, as the ice melted and into water and then flowed out into the ocean, that weight of that ice and the water then was lost, and this region rose up in altitude. It elevated. Just like, again, if you step in a boat, it sinks, and if you step out of the boat, it rises. The boat does. So think of the land here, in this case, the country of Scotland, rising like you stepped out of the boat, and it'll rise up in the magma. It is floating in the magma. Isostasy is what it's called. Glacial Lakes in Patagonia. Now, Patagonia is in South America. This east side here is this Buenos Aires. It's the Lake of Buenos Aires. And so this is in Argentina, and the west side over here will be Chile. So Chile and Argentina are the two countries here. And these are glacial lakes in Patagonia. Now, here's another glacial lake in Italy and Switzerland. And so it's a present lake that they have photographs of it. It's not able to escape, get out into the ocean. It can evaporate, of course, but it's continued up. Here's a big, huge lake in Russia, glacial lakes in Russia. So again, the glaciers here would form the boundaries and block this water. This water would come up. And so here's a vast, this is the Volga River here. I was in this region in the Volga River. I was in Yaroslavl. I'm guessing Yaroslavl it's up on the Volga, up north. I'm guessing I was about up in here somewhere is where I was when I lectured in 93 and 94 in Russia. And so I was in this region, up here somewhere, where my mouse is right now, right up in here on the Volga River. There's the Ob River, and this again is still in Russia, Siberia. And some more. This is another lake that was here, a glacial lake. And again, these glacial lakes eventually flowed into the ocean. Now, we have Bonneville and Missoula, and they're called Outburst Lakes because once they begin to flow out and cut a channel, they cut it very rapidly because a rapid flow of water will cut through even through rocks very quickly. There were outburst lakes when the Siberian lakes were drained, so this would put large amounts of cold water into the ocean very quickly, raise the water levels, and so we'd have some rapid changes in the ocean levels. Yes, this has happened in the past. And so outburst lakes have been observed in modern times by glacial ice dams and or moraines. Now, moraine is soil that's been pushed by the glacier like a bulldozer and formed into a dam by the glacier. There was Hubbard Glacier in Alaska. We're going to have some slides here and look at it in just a minute. And you can go to this, you can say Hubbard Glacier, and you can actually see a video of it. So Hubbard Glacier, Alaska, squeezes toward Gebert Point on May the 20th, 2002. The glacier is close to sealing off Russell Fjord from Disenchantment Bay. Slide 2 is this Hubbard Glacier image from July the 16th. The first one was May the 20th in 2002. This is July the 16th. The glacier has closed off the Russell Fjord from Disenchantment Bay. The water behind the glacier rose 61 feet in 10 weeks, creating a short-lived lake at that time called Russell Lake. The third slide, we're going to see it in just a minute. Hubbard Glacier is overwhelmed on August the 14th. And so we got a GLOF in the historical times. And so Glacial Lake Outburst Flood, GLOF, that's what that means. Here's a picture of Hubbard Bay. Here's the first slide, and the glacier is moving across here to seal it off. Now the glacier begins to form an ice dam here, and then there's a moraine as well as the glacier's pushed soil, forming a moraine to block it off here and form this dam here. And so finally it breaches on the 14th of August, begins to flow out. Notice the ice has a bluish color to it, just as glacial ice does. Now, what we find here is this helps us a lot to see what was going on. We actually have seen one of these in a small sense right here at this. We got pictures of it here, pictures of it. Now, we've been going about 45 minutes now, and I'm going to call a halt to it. We're going to stop here on Heinrich events and come back to this next week. And then we'll break until February of 2022. So, do you have any questions about this? Okay. Do then is all.